doesn't matter. Anyway, so our original problem was this. So first, we need to find the derivative, which was, this is going to be very lengthy, because we have to do product rule. Derivative first, times the second. Plus the first, times derivative of the second. Okay. Then you shorten it down a little bit. And then we need to find our critical points. So we end up setting this equal to 0. Now, through both of these, you can take out x minus 4 squared, which leaves us with okay, and then you take this x and this x and add it together. Then you add over, you divide, and you get x equals 1, which is our critical point.
Can I add something here?
Yes, of course.
Okay, so you said you can take out an x.
Yes.
So if you take it out, you could think of it as like x minus 4 squared times this, right?
Mm-hmm.
So then when you do your critical points, you have to set both of those equal to 0. So
Okay.
your critical points will be 1 and 4.
Okay. Then we need our sign line. Fixed, okay. So then you plug it in to your derivative, and this gives us a negative, and then a positive. And we didn't do this one, but I'm going to assume that it's negative.
It is actually not.
It's not.
Because if you put in 5 minus 4 squared, that's positive. 5 times 4 minus 4 is positive. So even though 4 was listed as a critical point,
Mm-hmm.
did the increasing, decreasing change there?
Oh, no, it didn't.
No.
So it wouldn't matter.
Mm-hmm.
Okay. Do you want to do the same thing here?
No.
Okay. Where's the eraser?
Are you going to do like increasing, decreasing, max and min?
Okay. Give me 1 second. I gotta erase this side. Okay. Where am I? Okay. So then that means that we are increasing from 1 to infinity.
And how come sometimes we have to break it apart at 4, but this time we didn't? We could just say 1 to infinity. Right. The times where you have to separate your interval is if it's a vertical asymptote. 4 was not, so we don't have to worry about that.
And it's decreasing from negative infinity to 1. Also, since on our sign line it went from negative to positive, that means we don't have a local max, but we do have 1 local minimum. So we plug 1 back into our original problem, which gives us 1 negative 27. And we also do not have a vertical asymptote or a horizontal asymptote. Okay. You should do domain.
Domain. For the domain, we set it equal to 0.
So with domain, we think about like what x can be. We know if there's a fraction, x can't be 0. If there's no fraction, then what does that tell you about x? It can be anything. So our domain would be,
Negative infinity to positive.
mhm.
So with our intercepts, in our x-intercept, we set the equation equal to 0, and we found it at x equals 0 and 4. And for our y-intercept, we put x made it 0. We found that y-intercepts at 0.
Oh no! Now it's gonna get a little tricky because the second derivative,
And if you
It's
need to
pretty
just go to a new page.
oh, that's a good idea, okay. Second derivative. Again, we have to do product rule, so. Okay, there it is. So that would be 3 times x minus 4, 2, times 1, plus 3, x times 4, squared, plus 3x minus 2, x times 1. And we can set that equal to 0. So then that leaves us. X minus 4, plus 6x times x minus 4 equals 0. So again, we can factor out an x minus 4. So then we can distribute our 3. Then combine them. So we have our inflection points as x equals 2 and 4. Okay. Then our timeline. One is a plus, two is a minus. I don't know what 5 is, because again, we did not do that.
If you put in a 5 to your second derivative, then you should get a positive times a positive.
Okay. So then, it's critical up from -3 to 2. Or to infinity.
Okay, is everybody following this? All right.
So it'll still be 2 to -60, but we just don't have to push.
Okay. So if your ordered pairs in, so we can put them on the graph, you said when you plug in 2, you got -16.
Yeah.
If we put 4 into the original, then you have 4 times 4 minus 4 cubed, which is 0.
So again, it wouldn't matter what it.
So it will be a point on the graph.
Okay.
And so these are the points. How do we mark inflection points on the graph?
The X.
The X's. So now we have to draw our whole graph. Can I go to a new slide? You guys have what you need? So we hit the x-axis at 0 and 4, so those will just be points. That's kind of the new piece that we added in, finding those x and y intercepts. Everything else is like we have been doing it in the past.
Okay, so then we have a critical point at, yeah, 2, -60. That's
That was an
point.
inflection
Oh, yeah.
point, so mark that one with an x.
-27,
That was your min.
which is also our local minimum. And then we have an inflection point at 4, 0. Oh, whoops, I put that as 0. There we go. And then we have another inflection point at 2, -60. Okay.
And plot your x and y intercept. So our x-intercept was 0 and 4, y-intercept was 0. So we've got that as well. Okay, so now we have to draw the graph. Here, do you want to keep it like this so you can study?
So it's decreasing and it's also critical up,
Concave up.
concave up, sorry. I'm gonna try to find this graph. That's kind of critical down, but I'm trying my best.
It is tricky. Okay, so that's the point where we now switch concavity and it's curving downward. And then from here it switches and it's curving upward again. So
Okay.
this whole thing is supposed to be curved up, but
Yeah.
kind of tricky to do. We'll just try to do an easy little fix there. Okay.
Any questions? That's
All
right.
right. Excellent teachers. Okay, so that was problem 1.